Hello, good morning, all of you. Today we are discussing about the sewer designing. This is related to environmental engineering for the sixth semester students of BTech. Design of sewer. What is sewage? Sewage is the mixture of water and waste water produced in terms as sewage. It is generally three types: domestic sewage, industrial sewage, and storm sewage. Okay, domestic sewage, the liquid originating from the domestic activity like cooking, washing, and bathing. Industrial sewage originating from the industrial activity. Storm sewage originating from the runoff due to the rain. Okay, and the combination of the domestic sewage and industrial sewage. Domestic sewage and the industrial sewage is termed as sanitary sewage. Okay, what is sewer? Sewer is the pipe which are used to carry sewage from one point to another point to flowing to carrying the sewage is known as sewer. And what is sewerage system? The art of collecting and treatment and finally disposing of sewage is known as the sewerage. Okay, the sewerage system are three types: separate sewerage system, number one. Number two is combined system. Number three is partially separate system. Okay, separate system. In this type of separate system, the all the sanitary sewage and storms drainage are flowing separate from the separate conduit. And in the combined sewage system, both the wastewater flows through a combined pipe. Okay, in partially both type of sewage system, both type of sewerage is flow partially, means sometime combined and sometime separately. Okay, next is design of sewer design, uh, sewer designing. About 80% of supply of the city enters into the sewers. Mean to say is, thus what is the sewer discharge? 80% of the water which are uh, which are coming out from the households, that is the sewer discharge. Manholes are provided at the intersection. Manholes are provided at the intersection for inspection, cleaning, maintenance between the two intersections, at the change of the bends, and at the change of the gradient, and at the change of the diameter of the conduit. Okay, the variation of the sewage is, so as showing in the graph, that the qw is the discharge of the water and qs is the discharge of the sewage. And at a particular time, for the discharge of the water is greater than, always greater than discharge of the sewage. Okay, for generally, if the data is not given about the discharge, then we will take as a maximum daily discharge is the 2 times of the average daily discharge, and maximum hourly discharge is the 3 times of the average daily discharge. Like this, any all the discharge is computed by the following relationships. Okay, we if the size of the sewer is less than 400 mm, is the size of the sewage is 400 mm, then it should be designed for half full run, half full run design करेंगे अपन. Okay, if the size of the sewer is in range in 400 to 900, then it should be designed to two-third of the sewer. And if the sewer size is greater than 900 mm, then it is designed at the run of three-fourth full. Okay, these are the standards for flowing the sewer, because we do not flow the sewer completely full, because due to some reasons. These reasons are accumulating. These free space are used for accumulating of the gases released by the sewer due to decomposition of the organic matter. Okay, and for the future, against unexpected increase in the population in the future के अंदर, if there is some expansion and some increment in the population, then this sewage system will be satisfied and sufficient for flowing the sewage of that particular community. Okay, for designing of the sewer, the maximum hourly discharge is required. The sewer is can mean to say is the sewerage system is designed at the maximum early discharge and should we check for minimum early discharge. Minimum early discharge, why we check at the minimum early discharge? Because sewage contains maximum many amount of many things like solids, that may be solids, that may be liquid, that may be in organic, that may be inorganic. So we have to flow all of we want that all the material should flow in the sewage. There should be no deposition in the sewage and no obstruction in the sewer. That's why we check check the sewer for the minimum early discharge. For maintaining the minimum velocity in the sewer, we need a self cleaning velocity in the sewer. Self cleaning velocity in the sewer. Why the self cleaning velocity required? Because if the velocity required in the sewer so as to avoid avoid of deposition of solid in the sewer. Okay, so how we calculate the self cleaning velocity? For measuring the self cleaning velocity, this formula is used. Vs equals to under root 8k divided by f multiplied by g minus 1 into g into d. What is g? G is the specific gravity. What is f? F is the friction factor. And what is k? K is the constant that is depends upon the solids of which type of solids which are flowing in the sewer. Okay, so minimum velocity, minimum self cleaning velocity for 1 mm organic matter is for generally and 5 mm organic 5 mm organic particles is 0.45 meter per second. This minimum velocity should be maintained in the sewer for not allow the deposition in the sewer. There are different generally in the sewer the organic matter means the inorganic matter size of the inorganic matter is the 1 mm and organic matter particle size is the 5 mm. Okay, for calculating the velocity of the flow in the sewer can be either using Chigi equation and by the Manning's equation. The Chigi formula is V equals to C root RS. Here C is the constant, Chigi constant, which is calculated by the Cotter's formula, as this is the Cotter's formula. Okay, and R is the hydraulic mean depth. R is the hydraulic mean depth, that is also called hydraulic radius, that is the wetted area divided by wetted perimeter, wetted area divided by wetted perimeter, and S is the slope of channel water. Okay, so this is the first formula for calculating the velocity. And next is Manning equation for calculating the velocity in the sewer, that is the V equals to 1 by n into r to the power 2 by 3 and s to the power half. Here n is the roughness coefficient, that is depends upon the material of the sewer pipe, s is the slope again, and r is the hydraulic mean depth, that is the wetted area divided by wetted perimeter. So for the maximum velocity of flow is limited to 2.5 to 3.5 meter per second for concrete sewer and 3.5 to 4.5 meter per second for cast iron pipe. So this is all about the sewer. Okay, for designing the sewer we have some hydraulic characteristics for of partially full and completely full, because as we discussed before that the sewer is not designed for the complete full. So what are the parameters? Generally this is the sewer and AB is the line of the flowing level. The water level is the shown by the symbol, so AB is the level. Okay, so and firstly capital D is the complete diameter of the sewer and small d is the depth of the sewer, depth of the sewage in the conduit. So how we calculate the diameter ratio? These ratio is required for the designing purpose point of view, so we have to find these parameters. So firstly diameter ratio, how we calculate diameter ratio? By the simple CD equals to OD. CD equals to OD minus OC. So by the simple triangle mathematics, we will find out the B by D ratio. Capital small d, we know that what is small d and what is capital D. Small d by d capital D equals to 1 minus cos alpha divided by 2. This is the diametrical ratio. So this is the hydraulic characteristic which is going to design which will help in the designing of the sewer. So this is the diameter ratio, and next ratios we will discuss in the our next video. So wait for our next video. Thank you so much.